Okay, starting to stream. It says we are live. Let me check somewhere else. Okay.
Yes, we are live.
Okay, good.
All right, cool. Excellent. Yeah, so welcome everybody and welcome to the stream on the GraalVM 22.1 unboxing. Yeah, so I have here with me Alina, who is the lead developer advocate for GraalVM. And we also have Fabio, who recently joined us and has done already a lot of contributions to the GraalVM tooling. And we are happy here to present today the 22.1 version of GraalVM. And as always, this stream is supposed to be interactive, so we will continuously monitor the YouTube chats. And if you have any questions, we will try to address them on the stream here. Otherwise, we will just talk about the main new features and show some demos. So yeah, so cool. Yeah, Alina.
Yes, thank you, Thomas. Hi, everyone. Indeed, we have GraalVM 22.1 release today. Super happy to talk with you about all the new stuff. And let me actually start sharing so we can get into details. So yes, so today we have our 22.1 release. First things first, as always, you can get GraalVM builds for JDK 11, JDK 17. You can get them from Github for Community Edition and from Oracle's OTN for Enterprise Edition, or which could be probably simpler, you can install GraalVM with our VS Code extensions pack or with Homebrew for macOS. We already updated the website, I believe, right? So we have the latest bits linked from here. So you can easily navigate, let's say, to Community Edition and get your bits from here. In fact, we now have this awesome new layout of the downloads page, so you can more easily find the builds for your platform. And let's see what's inside of this release. First thing I want to talk about is native image. So we've been working on the developer experience of native image for a couple of releases already, as you probably know. And in this release, we have a few new updates in this area as well. And first thing we want to talk about is so-called quick build mode for native image. This is something brand new, and we first introduced it in this release. So what this means, as you probably could have noticed, if you have a bigger application and you want to compile this native image, sometimes it will take some time, right? Especially for a bigger application, because native image has to do quite a bit of work at the image build time. So it has to analyze your whole application, including its dependencies, find all the reachable code, and then optimize it and compile it. And such a proper process is very important and very essential, basically, to how native image operates. But it could be simplified for development purposes to make your development process more efficient. And this is actually what we did in this release. So we introduced this quick build mode, which is based on the economy mode of the Graal compiler. So when you are using native image with the quick build mode, we will run the compiler in this economy mode, meaning we will perform fewer optimizations. And this way, the build process will be significantly faster. So to illustrate that thought, I want to show you this one application which we ran and benchmarked, and that is actually a very good example of GraalVM as a platform, because what we are running here is the libgraal, which is the Graal compiler itself, compiled with GraalVM native image. So basically, we are using our native image to compile the compiler that you then get in our builds. And as you can see here, we measured how much time it takes to compile it with native image in the default mode and in this new quick build mode. And basically, this quick build mode, this is works with the compilation stage, right? So what we're improving here is the compilation stage. And you see how much faster it is in the quick build mode. So in this mode, on the machine that we used, it only takes 7 seconds to compile it versus 38.6 seconds in the default mode. And the green charts, that is the impact on the overall build process, which includes other stages, not just the compilation stage. So you can see how much faster it is, right? And yeah, basically it's 81% faster in this new quick build mode. And it's fairly easy to use it. So for that, you just need to add this -ob command when you are running native image compilation step. And this is something you can try with our latest 22.1 builds. One thing to mention though, that is that we recommend using this quick build mode for development purposes. So this is basically to speed up your development process, where you mostly probably care about getting fast results, making sure things work correctly. But for deployments, when you actually are ready to ship your application to production, you would want to use the default mode because it optimizes for runtime performance and memory efficiency rather than build time. So basically use the quick build mode as you develop your application, and then use the default mode for when you're ready to ship it and deploy it. And yes, I think we can show a live demo of how it works, right, Fabio?
Yeah, of course. So this is super exciting because the questions that we're always getting is, why is my build taking so long? And for development purposes, it turns out you don't always need all optimizations, so we can turn them all off and make your builds faster. So I thought it would be fun to do a demo. If you could stop sharing your screen, I can start sharing mine.
That is a fair suggestion.
Yep. I was actually waiting for that. Hang on. So I hope you can see my screen.
Yes.
Yes. Good. So I was thinking maybe I should do something that lots of people do, is developing in the cloud, and VS Code actually makes that really simple. So here I am in a VS Code session, but actually using the remote explorer that VS Code supports. Which lets me log into any machine that I'm using. And I decided to go for a free tier OCI machine. So a free machine that you can get from Oracle Cloud, so which we can see here in the terminal. So this is Linux, but this is in fact an Oracle build and is running on Arch 64, because in the free tier, you get for free, you get 4 cores, A1 4 cores, and 24 gigabytes of RAM, I think. So I think I maxed out this machine. Yeah, it's got almost 24 gigabytes. So I'm using this. The UI is on my machine, but everything I do happens remotely on this other machine. So you can get one of these and reproduce everything that I'm doing here. So the first thing is a hello world, of course, and we can run the hello world. So of course we need to compile it first, and then I run the native image build on it. And yeah, we have extended the native image build output a little bit. So now you get to see information about the C compiler that native image is using, and that tells us, this isn't indeed an Arch64 machine. It also tells you about the garbage collector that gets compiled into the binary. By default, that's serial GC. And it also tells you, okay, this is enterprise, of course. So I'm using the enterprise build here because I can for free on Oracle Cloud. And that's I think the only way you can actually run enterprise for free in the cloud is on the free tier, right? So now I've done a normal build. This is a normal build. And what you see here is took 9 seconds for the analysis to do its job. And then we're doing some other things. You can read what's happening in each of these stages in our docs. And then the interesting bit is this one, of course, took 17.6 seconds to compile everything. And then we ended up with a 5.79 megabyte file, and this is everything that's included in the hello world. And in total, this took 38 seconds, right? So I can, of course, run the binary, and it will just print hello world. But let's rebuild with our new OB option for fast build. And then I rerun this again. And the first thing that you note is a big red warning to make sure you don't deploy this. It's just a reminder, and but it won't perform the way you want it to perform in production, and that's why we don't really recommend it. However, we do make sure that the behavior will remain the same. So there shouldn't be any difference except from performance. So sometimes the VS Code terminal breaks haven't figured out why. But what we can see here is that the analysis stage took 9 seconds, which is almost the same, 9.2. And but the compiling stage was actually much faster. So this is 4.7 seconds, which means instead of 38 seconds for this hello world, it's 24. So the difference is quite big, even for the simple hello world, right? But the new build output, of course, I can run this, and then it's just hello world. But the build output actually tells us a bit more, and I think I can explain some of what's happening behind the curtain. So what you notice is that the binary is a bit smaller, and that means that is a result of the different compilation step. So since we're using the economy mode of the compiler and turned off a couple of other optimizations, the binary is smaller. So again, this is for development purposes. I know that people want their binaries to be smaller, but that's not how you should be doing this. This is for development only, but I think it's a great feature. And correct me if I'm wrong, Alina, but I think this is actually the result of an internship project, right?
Yes, this is an internship project which made it into mainline, and yeah, this is also a shameless plug here. We are looking for more interns as well, meaning if there's more people who want to help to make a native image and GraalVM better, always welcome. And yeah, a lot of our interns are very productive and really awesome, and this was one of these really great intern projects that made it into mainline really fast.
Okay, let's see. Are there any questions? The quick build is, of course, not limited to enterprise. It's also available in community edition, of course. Yes, I hope that answers the question. I don't see any other questions.
Yeah, and so what is the size of this hello world here?
4.79 megabytes,
right?
Or 5 megabytes. Yeah.
Yeah, and so sometimes people ask us, like, why is our hello world 5 megabytes and why is it not like 500 kilobytes, right? And so one of the things to say here is that in this hello world there is still a lot of functionality from the JDK that we include here because it cannot be proven that it might not be needed at runtime. So there is code related to time zones, related to localization, for example, related to big integer printing. And one of the things we will be working on in the future is to allow you to manually disable some of these functionalities in case you're really interested in a very small binary. In absence of that, you can still also use the Upx compression mechanism. And maybe Fabio, you show that quickly.
Yeah. Well, I downloaded the binary on my local machine. I didn't have Upx set up of that on the remote machine, but this very binary here is the same. I hope you trust me. So this is around the same size, different architecture, but it prints a hello world. And when I run it through Upx, I actually get this binary, and it runs the hello world, same thing. But when I compare it, this binary is actually just 1.6 megabytes in size. So this does come with a disadvantage because the way Upx works, it needs to essentially decompress the binary at startup. So that means on my machine at least, and your mileage may vary. So time here is like very, very quick, but time here is a bit slower, right? So that's the trade-off that you make.
Yeah, so there's a trade-off here between using Upx and therefore consuming more CPU at startup time. This trade-off might, however, vary based on how fast your machine is compared to also how fast your disk is. On many powerful machines, you will find sometimes the compressed binary even starting faster because the transfer of the data from the hard disk might be slower than the machine just unpacking the content. And yeah, in general, a tool like UPX is really good here in case you want the small binary sizes, which can be very relevant also in cloud setups where you want potentially transfer Docker images between servers and run them on different servers. And for such cases, UPX typically gives you a 3 times advantage. Now, one of the developments, other intern projects that are currently underway, but they are not yet finished, is that we want in the future at some point include such a compression as part of our own system, such that you don't need an external tool like UPX. But this is sometime in the future. It's just one of the areas that we continue working on. And the other area that we continue working on is the build speed. As you can see here, our fast build, this is just the first version of the fast build where we make the compilations faster. We think there's also still some room in other parts to improve compilation speed. And you could see kind of from one of our blog posts as well that we are continuously improving compilation speed and footprint. And this is really a process where almost every 3 months when a new version comes out, for at least for the main type of programs that we target, like Spring applications or other web applications, you get some incremental improvement.
Yeah, that is a good point. And yeah, sorry, go ahead, Fabio.
I just noticed there's another question coming from Jonathan regarding resource consumption. So I don't think we have any charts on that right now, but that's a good point. That would be interesting to see. I would assume that the Graal compiler in economy mode doesn't need as many resources because it's not performing all optimizations, but we can certainly have a look here. So peak RSS for the build is 2.56. And then in the second build, it's 1.74. So maybe that's because of the
that's very likely because of the economy mode here.
Yeah, it could be.
Yeah, because the peak.
We can also have a look at the value here, which is right after compiling. It's at 1.22. That's used heap, and then the usage of the heap here is at 116. So maybe that's because right before everything, the compilation step happens, there's a garbage collect. So these values actually not as interesting as the
they can vary, but in general, if in the previous setup the compilation step was the bottleneck in terms of consumption, you should see a relatively large improvement, because some of the more sophisticated optimizations that require a lot of memory are just disabled in this mode, and this should allow it to compile on lower memory machines. But again, we would recommend this mode still primarily only during development, as for the final deployment, you probably want these optimizations applied to get to the relevant peak performance for this native image.
I saw another comment regarding garbage collection. There's some improvements in JDK 18. I'm not quite sure which ones CC is referring to, but in EE you get to choose different garbage collectors. So if you click on the documentation here, it will tell you that in addition to serial GC, there's also epsilon GC, a GC that does nothing, which is useful in some cases, for example, when you have small scripts. But we also provide the G1 GC for Enterprise Edition. And again, you can run this for free for development purposes and for free on Oracle Cloud in production. So that's,
right, yeah, and we in general, like improvements to the G1 GC is something we also pull from Open Jdk, because our garbage collector is based on the one from Open Jdk there. Additionally, we are starting at the moment to add ZGC support. Also, this will take still a while until we can have full ZGC support. And initially, we will add the ZGC support for the JIT mode, because we think for smaller heaps in the mode of EOT compilation, it is less of an advantage to use a garbage collector like ZGC. We recommend their G1 for small heap configurations. But yeah, you can expect in general with some delay garbage collection innovations that land in Open Jdk to be also then used in the GraalVM setup.
Okay, I think that was all for the questions so far. I don't see any more, so probably we can move on. A few more things. So to add to what Thomas was saying, right, we will keep working on this quick build mode. Right now, it only applies to the compilation stage, but we also have plans to improve other build stages as well, in addition to compilation. And we are also thinking about improving the runtime performance in this quick build mode specifically. So expect more changes coming up to this mode. And also this is, as we mentioned, the first release where we introduced quick build mode. So we are looking for your feedback. Please give it a try, and please share your feedback with us on our community platforms. That will be very helpful for us. So that was the quick build mode change. Now, one more thing Thomas mentioned a bit already is improvements to the image build time and size. So this is something we've been working on over the past couple of releases. And in this release, we have an update again. So here we are measuring those two metrics, image build time and image size, on the example of Spring Pet Clinic application. And you can see how build times and the image size as well got better over the past couple of releases, including 22.1. So for example, in this latest release, image build time by default is 2 minutes, 5 seconds, and it's also almost twice as fast with this new quick build mode. So that is another improvement that we have for native image developer experience.
Yeah, and so this is the important part that we're targeting. It's like Hello World is kind of nice, but in the end, our main target are things like here's Spring Boot applications, like here I think it's Pet Clinic, so really large applications. But you can see for these large applications, there is a very substantial impact. And with this new quick build mode, it's now less than half the time to build such an application on 22.1 versus 21.1, which is just 1 year of development. And yeah, you can expect this to further improve as we continue developing in this area. Now this flag -OB, I guess it stands for optimized base or
optimized build.
Optimized build.
Yep.
I see. Optimized build. Okay, got it. Okay.
Okay, and we have a couple of questions in the chat, right? So one is to share the article that we are looking at. I already did that. That is our Medium blog, right? And another is asking whether we have a timeline for GraalVM Labs JDK build for 19. Does anyone know about timeline?
Do you want to take that one, Thomas?
Okay, yeah, so I don't have a concrete timeline, so we are still very focused on getting support for JDK versions beyond 17. Like the latest release we have at the moment is on 17. I cannot give a concrete timeline here, but we're working on it, and you can expect us, yeah, typically be a few months behind in terms of after a certain Open Jdk release of a non-LTS build is coming out, it will take us typically a few months to adopt that for a GraalVM build of this version.
Okay, thank you, Thomas.
And there's another one coming from Brian, whether there's a way or whether we can work on something that supports compiling jars into multiple shared libraries so that you can use them through the service loader API, like modular native image apps. That sounds very specific to me, but something like this is already possible, I guess, and you might not know about this. It's happening in the background, but something like this we already do with our truffle languages, because most of them are compiled with native image into a shared library. And we in the last couple of releases, we moved them to what we call language libraries. So these are actually native image shared libraries with interpreters for our languages that we support, and these are being loaded as you need them in the background for you. So this is already possible in some way, but yeah, I don't think we currently support that as an official use case for other setups.
Yeah, and I mean, this suggestion is kind of interesting. It's certainly an interesting idea for the team, because yeah, we have also a way to, for example, have native image isolates where you can run multiple native images within the same process and load them into different isolates. The thing which is missing, I think, to get what you want there is to connect those via the service loader API, which might be quite possible. And for the other aspect that is related to this is where, for security aspects, we are working on a setup where you can run a native image or a truffle language context in hotspot, but it's loaded like extra. It's not running on hotspot, it's like loaded extra, and then those two things are connected. So it's a very interesting idea, Brian. Yeah, so we have a few projects related to this in the works, but yeah, what is currently not possible might not also be possible in the future. We would always see these two elements as distinct, so you would have a very specific API, could be service loader API between the two elements, between the host application and the guest application. So what is not possible for us is kind of something that executes as a full native image, is just compiled in different times. So this is not possible because of we need this full closed world mode to get the primary optimizations of native image done. We have also a question from Matt here. Hi, Matt. It's not released until it's on SDKman. When is it on SDKman? Yes, typically the SDKman folks are very, very fast. So I expect it to be there really, really fast. If somebody's in the chat, let us know. But yeah, I would expect within the next 24 hours that it's there. Typically they don't take longer, I think. And yeah, it's awesome. Thanks to SDKman for taking care of this and helping here with the distribution. Another question, is the image size related to the runtime bundled in the exe file? Yes, so the runtime that is bundled in the executable is a constant overhead to image size. But the runtime is relatively thin. It depends on the garbage collector you choose. Therefore, choosing, for example, epsilon garbage collector helps with image size. There are also some aspects of the runtime you can disable to make the image smaller, like you can disable parsing of arguments on the runtime image, and this also makes the runtime smaller. But in general, the runtime as a whole, it's not so big in the whole file. Like Fabio, can you quickly go back to the Hello World breakdown of packages? Yes, it was somewhere here, right? Do we still have this in this terminal? Or the terminal history is no longer here. I think you're muted at the moment, Fabio. Yeah.
Oh, sorry.
Yeah.
I think it's gone. I cleared it up for the next demo. But,
yeah, we can just run it again to show kind of how you can.
Oh,
you need to have the class name. Yeah, class name. So it's a capital.
Oh yeah,
H,
sorry. Yep.
Capital H. Yes.
Yeah, I've been responding to the questions in the chat.
Yes. So, yeah, so this is reachable methods, inlining methods, and so on, but I'm interested in the breakdown of code that will end up in the image. it's creating the image now. Yes. So here you can see the breakdown of code, and here you can see some of the aspects that are runtime related. You can, for example, see the SVM core gen scavenge package here, which is one part of the garbage collector. It's 100 kilobytes. It's not all of the garbage collector, but it's one of the parts of the garbage collector that is included here. You can see some SVM core reflect 100 kilobytes, some SVM core code 20 kilobytes. So here we can see the top packages of the runtime already make about 500 kilobytes. So somewhere between 500 kilobytes and 1 megabyte at a runtime. But the biggest problem for images like Hello World are aspects of the JDK that we throw in, specifically the time zone database, where you have time zones. Every possible time zone has quite some data associated with it. And also localization databases are quite big, and those are currently added to the image. And so in Enterprise Edition, we have a slightly more sophisticated way to strip down the image. This is where in Enterprise Edition you will see the Hello World substantially smaller at the moment. In the future, we think also for Community Edition will be some flags available such that you can disable certain aspects that you do not want to have end up in that image. But yeah, as I said, on the other hand, for us as a team, it's always like, do we want to optimize the Hello World a lot, or do we want to optimize larger applications, larger Spring applications? And we think that the large applications are actually more important at this stage of the project. And so this is why we are focusing most of the energy rather on the larger projects.
Okay.
Shall we go back to the release blog post?
Yes, you can share back to the release blog post. There's one more question that I can answer, if I may.
Maybe we should do an Ask Me Anything round. This is good.
I was suggesting this last time. We should absolutely do it, but please go ahead, Thomas, and answer.
Right, yes. So the answer, like one other question is regarding like how we work with Open Jdk. Yes, so typically when a new Open Jdk version comes out, we pull in changes into our Labs JDK, which is very close to Open Jdk. So we do not have a lot of modifications in Labs JDK, it's just a few minor ones. But the component that is more sensitive to Open Jdk changes is native image, because native image is relying on initializing certain JDK classes and caching the result of this initialization. And also minor changes in JDK can then make problems for native image. And therefore, we always have to first iron out the problems, make sure that all of our tests and gates pass for a certain Open Jdk version. And this is why it takes some time until we're confident enough to give out such a version to users. Like, you know, the smaller programs, Hello World is probably gonna work immediately or like very, very fast. But like we always need a longer period of time until we have made sure that all of the larger programs then also work with a new Open Jdk version.
Okay, awesome. Thank you, Thomas. Now, a couple more changes in the native image component. So one is that conditional configuration, which we introduced a couple of releases ago, can now be generated with our tracing agent. And conditional configuration, if you recall this, allows you more precise configuration, which in turn can reduce the overall size of a native executable. That is one change. And another is that we now changed the default behavior of the native image runtime to be more aligned with how you execute your applications in the JIT mode. And in particular, that is related to how the classes are now linked and required at the image build time. Fabio, do you want to quickly talk about this?
Oh yeah, sure. So the way it used to be prior 22.1 is that native image would just fail if a class that it thinks is required is not there. And that means if you have code in your Java application that is actually fine because it's catching a no class def found error or something like that, or class not found exception, something like that, and provides a useful fallback alternative. And you want to use that. That was quite tricky to do with native image because it would just fail. Your build would just fail. So now we've aligned that behavior with how the Java command works. So that means now your application will compile, but it's possible that a class not found exception is thrown at runtime, right? So that means in some cases you do want to make sure that your build still fails for a specific class or a specific package. And that's what we provide with a new link at Buildtime option. So you can run this in different ways. You can provide it on the command line, and then it's turned on globally. And that essentially gets you back the old behavior. And then there's other ways that you can find in our docs. But here we also mention that you can provide package names or even class names to make that work. And that is just to make things more aligned with the Java command, so you can use a native image for more Java applications as a drop-in replacement on the command line.
Awesome. Thank you, Fabio.
Yeah,
so
I'm actually
minutes in, we are just done with the first section of the blog
I'm actually so much more excited.
Another major update in this release is that now we have our official builds for the Apple Silicon.
Oh, I'm guessing that's why. Yeah, she's dropping out. Yeah, Thomas, are you still there?
Yes, I'm still there. Yes. I think Alina just dropped out.
Yep.
But okay, I think Fabio, it's on you to continue. No, Alina's back. Alina's back. Okay.
There she is. That sometimes happens.
Are we still live?
Yes, we're still live. We're still live, Alina. No worries.
Awesome. Let me screen share again.
Yes.
The charms of Zoom.
I was talking about such an exciting feature. What a bad time for Zoom to fail. But anyway, we were talking about Apple Silicon builds. And I was saying that this was one of highly requested features in the community. If you look on our GitHub, you can see this issue was actually filed by Fabio back at the time, and I believe he wasn't even on our team yet, right? But he was very active in the community. And this was highly discussed. We have something like over 100 comments on this issue. And in fact, we got a lot of help from the community. So they helped us by providing feedback, by helping test our builds, and helping make this platform available for GraalVM as well. So now you can get them from our official builds, and they would come with the following components. So you get JVM with our compiler, you would get native image by using GU, you would get JavaScript and Java on Truffle, and support for other components, such as, for example, Python, Ruby, and so on is on the way, because we also have to implement the LLVM runtime. That is that. So this is the first release when it's actually available, but we already heard a lot of great feedback and happy community members using those builds. So you can see some of that on our GitHub issue. And there is this nice blog post from, I believe, Josh Long from the Spring team, who already tried our developer builds. And he was, I think, quite happy with them because he built this application in something like 40 seconds, I believe. And yes, the application started in 36 milliseconds, which I think is quite cool.
Yes, also the build, the native image build is really fast on these machines. Some of the developers on the team that are using this new silicon from Apple are also very happy about the build times. The native image build is really strong on these machines because native image is parallelized, of course, to build, and therefore those machines with high number of cores do really, really well on the build times.
Yep, that is that. So that was another big update in this release. And to talk a bit about other components, so that was a nice change in Python. So what we do now is we added support for frozen modules, which means we eliminate that overhead coming from loading and parsing those modules, because they are now come in the binary, in the bytecode form, which makes start to REPL and much faster, and also use way less memory. And as always, we continued our compatibility work, improving support for a number of packages.
Yeah, the Python team, by the way, in future releases, Python will get their own interpreter, like bytecode interpreter. Currently, it's an EST interpreter. So you can specifically on the Python side, you can expect more warm-up and footprint reductions on our side. And we are quite heavily invested in this area still. You will see in the future better ways on how you can here use some Python machine learning libraries from Java.
So that was Python. And regarding Ruby, one nice change is that now we have full support for foreign exceptions. And I think we will have a separate dedicated blog post to talk about it. So stay tuned. That is that. And for JavaScript, we've now introduced experimental engine caching support for JavaScript and for Node.js application. And that is a feature that is intended to eliminate warm-up coming from operations such as loading, parsing, profiling code, and actually compiling it. And I think we have a demo for this as well, right, Pepper?
Yes, right. So let's see if I can share my screen.
Go ahead.
And yep. Let's see. So yeah, I've shared this before. Yeah, I'm using the Octane benchmark. So that's a benchmark suite that is still has some nice benchmarks in there. And yeah, I want to run the Navia Stokes benchmark, which does some heavy numeric computations and array computations that you can see here. Don't want to go into too much detail here. I much rather want to run the benchmark in the terminal, and I'm running it, of course, on the release. But this is an enterprise-only feature, and the team has asked me to make sure to stress this is an experimental feature. This is something that we're working on right now. It has some loose ends here and there, and there's still low-hanging fruits that we are aware of and that we want to make sure is fixed before anyone uses this in production. However, I think it's a really cool feature because it answers one of the long-standing questions that people have. What are we going to do about warm-up? And in one way. So let me show you how that works. So let me fire up my demo shell, and let's run the benchmark on this machine. So what you usually see is some sort of warm-up behavior. So here, the first two iterations, they were actually quite slow. And you didn't see this, but the Graal compiler was optimizing it, performing partial evaluation. And then at some point, it would reach peak performance, and then it stays at this peak. So this is the theory, and this is what you see here in this particular benchmark as well. Your mileage may vary if you're using a different benchmark or if you're hitting a bug, performance bug, for instance. But yeah, this is what this benchmark looks like right now on this machine. So let me rerun this benchmark, and this time I turn on trace compilation. So this will flood my terminal a little bit, but don't be scared. I'll explain. Then we unlock experimental options. Because this is an experimental feature, I trace the caching, the engine caching, and I say I want to store the cache in this benchmarks.image file. So this will be a file, okay, on this machine. And of course, I want to run the benchmark. So when I do this, I get, like I said, lots of output. But if we look at this, for example, here's a function called query, and this is part of the benchmark. And this was invalidated, de-optimized, and then at some point, hopefully re-optimized. Yeah, here it was re-optimized. And this happened in tier 1. So this is like information about the compiler. So eventually, we get the first result, the first time there's a score, and the higher the score, the better. Should have said this a bit earlier. But here, it's the first time we get a score. But still, the compiler is still working its way through this. And then it has reached very good performance, very good score, and then it's optimizing still and de-optimizing sometimes, and then eventually it will reach somewhat stable performance. It no longer compiles anything, right? So it's essentially being done jitting, if you will. And then what you see is the effect of the other option, the trace cache. I'm tracing out. I'm interested in seeing information about this new engine caching that we're working on, and what we can see here is that the policy is that it should persist everything that is hot. and it found one root, and then the compiler was still compiling something, and then before we're persisting the engine, that's if you're familiar with our SDK, the engine is the thing out of around a language that runs everything. And inside the engine, there's multiple language contexts, and that the engine we can actually persist, or a part of it. So it took 70 milliseconds to persist it, and then it put everything into the file, and it found 3 sources and 187 function roots and so on. Not so interesting. What's interesting, though, I think, is that there's a file now, this benchmarks image file, and this file has around 3.3 megabytes, so it's relatively small. I would say it's still way too big, and we know it's way too big, but there's still, like I said, low-hanging fruit. We can make this better. But now comes the interesting bit, right? So I said, I run the benchmark, the compiler does a lot of work, and then we're reaching peak performance, and the compiler is done compiling. So now I'm running the same command again, tracing the compiler output and tracing the cache, but this time I'm loading the state that we persisted in the previous run. And so instead of cache store, I use cache load. See what happens. So it tries to load the image, and sometimes this can fail because it's experimental. It has loaded the 3 megabytes, everything from the file that we have before, and it has patched the engine, and the benchmark runs at peak performance from the very start. And there's no single activity that we see from the Graal compiler. So in this run, the Graal compiler did nothing because it can just reuse the work that it has done in the previous run. Right, and that way you can run, for instance, a Node.js server against your workload, and then persist everything to disk and start the server again, maybe even on multiple machines, and reuse that one file that essentially holds the state from the compiler, and to get instant warm-up, instant peak performance. Does that make sense? Let's see. Are there any questions? Did you notice anything?
Yes. Yep, there is a question from Vladimir saying, could a JavaScript script be parsed during inactive image build time and later evaluated during runtime?
Could a JavaScript be parsed during native image build time?
Yes, so it is possible. Like we sometimes do this where during native image build time we would prepare a whole context with existing code, and some of this context can also be then persisted as part of the native image. If you have a Java application that involves some JavaScript, you can do that. Now, the feature that Fabio is showing here is, however, a little bit different. Here, we are not only parsing the JavaScript file. Here, we are executing the JavaScript program, and we are caching not just the parsed information, we are also caching the whole machine code. And the way you can think about this is sort of native image, but for dynamic languages. We currently target primarily JavaScript, but we will in the future also target here Python, for example, and Ruby. And then you can avoid for the dynamic languages the startup time. Now, native image is still for static languages superior, because with this caching here, you get a better startup, but you do not get a better memory footprint, or you don't get a better, you don't get an improved security or anything. Whereas native image provides more than just the startup. It provides also better like global optimizations of the application and better memory footprint. So, but still, if you're interested in startup specifically, this can be an interesting option. And the areas where this is relevant is specifically in the areas of cloud functions or Lambda, AWS Lambda, where you might want to consider warming up your Lambda function and then deploying with such a cache, such that you don't spend any time, and in this case then also money, effectively always warming up your JavaScript function.
There's a question from Chris regarding licensing, EE licensing, targeting AWS Lambda. Thomas, you want to take that?
So in general, like, yeah, the licensing is for most like medium-sized to larger customer is like very individual. So meaning we like if you have such a question, like, yeah, send us an email. We will get you in touch with the relevant person that is responsible for that. Yeah, we understand that the per core licensing and so on is the per core licensing doesn't make sense for something like AWS Lambda, but in general the official per core licensing or the list prices that are published, like in general, I would even like for other use cases always just try to get to an individual agreement that fits your needs, and we are very flexible there, meaning typically the license fees would be here sort of would be calculated based on like, yeah, how much does Enterprise Edition help you, how much money you save in your cloud, how much faster does your application get, and then from this we would then come to an agreement of like how much you would contribute for this to the GraalVM development in form of an EE license. So I wouldn't get hung up in general on published list prices and their configuration, but if you really want to have commercial support and the best version of GraalVM available, yeah, really just contact us. We will get you in touch with the relevant people that can also help evaluate your use case. We do a lot of proof of concepts where we are working with customers and working on proof of concepts within the system to prove the value. And yeah, so we're very interested in that, of course. And but such a question cannot be answered like in a general way, but has to be then based on individual case.
Okay, thank you, Thomas. And we have something like 10 minutes left. So I was wondering, okay, Fabio you already gave up screen sharing. I was suggesting to do the enterprise demo, right? Maybe?
Yeah, sure, we can do that too.
I can talk about it as you set it up, right? So we simplified.
Go ahead.
Yeah, I just want to say that we have simplified getting started with GraalVM Enterprise, right? So you can now easily sign up to use GraalVM Enterprise build from either VS Code, which I assume Fabio will now show, or you can also use it in your CI/CD workflow, such as, for example, Github Actions, because we now have this new mechanism of how we can easily review and accept enterprise license and get it to work in your system. So let's maybe show it.
Yeah, so this is the GraalVM extension installed on the remote machine. It even works in the remote setup. And yeah, as Alina said, we've made it a lot easier to get started with Enterprise Edition. Not just because we want everyone to use Enterprise Edition in production, but also because Enterprise Edition comes with lots of very useful development features that you can actually use for free. So you can use EE for development and then still deploy with Community Edition if you want, and you should be fine. What I have done here is I've already installed a bunch of them, but from the release for this specific machine, the Community Edition, which I set to my active Java home in my shell, the Enterprise Edition that I used before, and another Community Edition in Java 11. And here I can download and install more. So the one that's missing is the Java 11 EE. So I can click on EE 2021 and then JDK 11 and say I want to store it here. And then it will ask me for my email address. Yeah, I do have a corporate email address. So hopefully I'll get this right. So now I'll get a notification that an email with a license has been sent to my account, which just arrived. So yeah, it has the license inside. I don't want to show all of this, but what I can show is I just clicked on the link, and yeah, I just verified that it's okay that I want to use Enterprise Edition. Just have to make sure that you have accepted this, and now I can continue. And now it's downloading GraalVM Enterprise Edition in 11, and it will install it. And I can set this as my working GraalVM or as my active GraalVM installation. What it has also done is it has generated this new download token for me. So if I actually go here and paste it, you can see that the download token for my email address is this thing. And this thing is actually quite useful. So I should have said before I did the demo that I have removed any token that I have previously installed on my machine before doing this, because now that I have done this, it has created something on my file system and has persisted this information. So now I can go and for instance, this is the new one, and I can open this and I can say I want to download native image. And now it should install native image. Yep, starting to download native image. Oh, this is actually Community Edition, but this also works in Enterprise Edition. Here it is. And now it's reusing the download token that was generated previously. So now native image is installed. And in case you forgot about it, you can also look up the token with GU. So this should be identical, and it's stored in this config file. Well, why am I telling you this? Well, because you can use the token in your CI/CD setups. And one thing that we launched in the last couple of months is an integration with Github Actions. So let me copy this into my comment, into my clipboard, and let's do one more quick demo, hopefully quick. So this is the Github Action that you'll find. It helps you to set up GraalVM, and it has now support for Enterprise. Yeah, let's do the quick Hello World template. So this is a self-contained example. What I can do is I can simply just go here and say I want to create a new repository. Let's call it Hello World 22.1. Yeah, and make it private, because I will generate some enterprise binaries with that. And now that I'm in here, I can do everything from here, actually. We have to create a file in this workflows directory, and let's call it main YAML, and I just copy and paste everything from here. Okay, good. So what does this actually do? So it has a new target with a new action that or workflow that has this name, and it will always happen on push and on pull request, has the name Hello World, and then an operating system. And here I'm using the build metrics. So I'm running this on macOS, Windows, and the Ubuntu. So what does it do? It checks out this repository, and then it uses our new GraalVM action using the latest release with Java 11. And then I also want native image, and we need to provide this token to avoid rate limits. So good, so far so good. So in the next step, we create a hello world. So this is a one-line hello world piped into this file, and then we just Java GC it and run native image on it. I guess we can do -OB to speed up everything a bit, right? And then we run hello world, and finally we upload that binary. And just to make that clear, let's add C here. So now I commit this file, and it's a single repository with this in here. And hopefully I've done everything right, because now there's a new job for this commit, and it runs on macOS, Windows, and Ubuntu. So yeah, hopefully GitHub Actions is not down, and we get a hosted runner in a couple of seconds. But so what this does, well, all of these runners are AMD 64. So if you want to run on Arch, then you need to provide your own runner. And yeah, it's already setting up GraalVM, and this is using by default the Community Edition. So we don't see any output because I'm guessing it's downloading the file of GitHub, and then eventually it should start building the hello world. But while this is happening, okay, here we go. Now it's extracting everything. Maybe we get some more output. If we don't, we can continue. Yep, now it's adding GraalVM CE 22.1 to the tools cache. So if you're using a self-hosted runner, that's important. Has now installed native image, and off we go. Here's the warning that we've seen before. So the native image build is starting now, and yeah, this is now we can now follow this. We've seen this a bunch of times in the stream. So while this is running, I can show you what you need to do in order to turn all these community edition builds into enterprise edition builds. So what I do is I open a new tab and I go in here and change the file. So what we do is we look at the template. So the template tells you how to set everything up, including how to get the token. And then we copy this single line. It's the GDS token option, which we need to provide. So I'll just add this. And the secret is called GDS token. So that's something that GitHub provides. We also link the instructions in the README that you've just seen. So, but before I can commit this, I need to create the secret. So I go to settings and then actions, and then well, secret actions, and then I can add this token. And of course, I lost this from my clipboard. So let me copy that. And nope. This is hopefully my token, all of it. So now I have secretly stored my download token in GitHub Actions. So now I can go and say, do a new commit, build with GraalVM Enterprise. And yeah, let's make that a bit clearer. So this is GraalVM EE now, and off we go. So let's see, in the meantime, this has completed. So in the summary, we now get to see the build job metrics, macOS, Ubuntu, and Windows. And here are all the binaries. So I can download them from here and run them on my computer. And of course, you get all these goodies that you get from continuous integration. I'm building this on, I may be building an app on my Ubuntu machine on Linux, but yeah, I can run my tests and native image builds and whatnot also at the same time on every push on macOS and Windows, and make sure that all my users will be happy with those binaries. So here I can just click on this and get a dump, and then a zip file, and then unzip it and run it on my machine. If I look at the other build that I just triggered, we now have machines here too. So yep, we came at a good time. I just downloaded everything, and hopefully I did everything correct. Yes, I did. So this is GraalVM EE now using Native Image Enterprise Edition, and we should see this in the build logs as well. Yep. Here, this is Enterprise Edition. So once you provide this, all you have to do is provide a GraalVM download service token, this GDS token that I was talking about, which you can easily get with our GraalVM updater, the GU utility, or VS Code. And then yeah, you can run on GitHub Actions, or and that's, I think, described in the release notes for Enterprise. You can set an environment variable which will be picked up by the GraalVM updater. So you can do this in any CI, including your internal CI infrastructure. So here I ran on Ubuntu. Let's maybe pick macOS just for a change. So this ran on macOS with GraalVM Enterprise, and same build output. It printed the hello world and uploaded the binary. So now that, well, hopefully Windows will be done any second. It's funny that the Windows build machines take the longest to schedule, but yeah, should be there any second. And then, yep, already done the analysis. And now that we're running with the new quick build mode, yeah, compilation should be relatively fast. Let's see, inlining methods now compiling, and then we should almost be done. Yeah, 10 seconds. Here we go. All good, all green. Let's make this green, and Yep. So now here, hello world binary is EE, and what you can see is that the binary size is of course much smaller because we're using Enterprise Edition now. And yeah, that's the demo.
Excellent. Thank you, Fabio. And we are a bit over time, so I
sorry.
think no, it wasn't about you, right? It was about what I want to say next. So I think we can skip the rest of the updates. Everyone can read them in release blog post and release notes. One thing I do want to say, though, is that we want to acknowledge community contributions in this release. So in every release, we have quite a few contributions from the community, right? That could be code contributions or issues reported to us or any feedback shared with us. But here in particular, we want to highlight a few things. So for example, several new JFR event support was added to the native image by the Red Hat team. Also, quite a bit of things in Truffle Ruby have been committed from the Shopify's team in this release. And the Apple Silicon support, as you already saw on GitHub, was supported highly by community by sharing feedback, testing builds with us, and yeah, helping us make it happen. So thanks to everyone in the community for working with us on this release. And as I said, you can get it from GraalVM.org, both community and enterprise bits. So get them, test them, and share your feedback with us. That will be very helpful. And maybe there are some last minute questions, but I don't think that we have any, right?
No, I think it's good. Thank you. Thank you everybody for listening. Thanks, Alina. Thanks, Fabio.
Of course.
For awesome demos and getting through the stream here. As usual, we have a Slack channel, a public Slack channel where you can reach us directly. Feel free to ask questions there, and tell everybody that you know about the new release, and you can also let us know what you want to see for the next release. Because yes, our release schedule is very tight. Like every 3 months, there is a new version, and so. Before the release is after the release. After the release is before the release. Sorry, which means while you can now enjoy the new version, the team is already working on 22.2, and you will see many more gradual improvements in 22.2 as well. Test out the 22.1. Give us feedback, and so we can continue making GraalVM here better. Both for Java applications, but then also the other aspects of GraalVM that you will in the future hear more about around Python, Ruby, and other languages. Thank you very much. Thanks everybody, and have a great day.
Thanks everyone. Bye.
Bye.